Hello everyone. Today is lecture 6 for subject information theory and coding, and in this lecture we will discuss about mutual information and channel capacity. Uh, Before that, whatever we are discussing in the last class, okay, that we can recap in one slide. Uh, that was the joint entropy and conditional entropies. Okay. That we have discussed that joint probability and their probabilities, as we have discussed, that is there is a two sources x y and their joint probability, that is p x j y k. Okay. Suppose here there are n symbols in a source x and m symbols in a source y. Okay. Then as per the property p x j y k is nothing but equals to p y k upon x j into p x j. Okay. That is the conditional probabilities when y k, conditional probabilities of y k when x j given into p x j, then it is the joint probability, or it also can be given as p x j upon y k into p y k. Okay. This is the probability of x j when y k given into probability of y k, that gives the joint probability. We have discussed also that is summation of joint probability p x j y k over j, it equals to p y k, it equals to p y k, while summation p x j y k over k 0 to m minus 1, this is p x j. That can be proved very easily. Okay. These properties that we will use in next slides. Equation for joint entropy of two sources. Using the joint probability, we can write the equation for the joint entropy. Joint entropy mean H of x y, this is equivalent to summation, double summation j 0 to n minus 1 k 0 to m minus 1 joint probability p x j y k into information in that joint entropy log of base 2 p x j y k. This is the p basically, log of base 2 p of this one. Okay. This is the equation for the joint entropy of the two sources. Okay. Through Venn diagram we can see if this is source x with its entropy h x, this is source y with its entropy h y, then the uncommon part, it is the conditional entropy h x upon y, that is the entropy of x when y known, and in y side the uncommon part, it is known as the conditional entropy h y by x, that is the entropy of y when x known, and this part is the represented by I x y, and I x y is known as the mutual information. Okay. That is the mutual of the source x and y, or meaning that the some common symbols of the source x and y found in this region. Okay. Then relationship that through Venn diagram we can see. Now, in the relationship joint entropy Hxy joint entropy, it is given as joint, then this part complete this part plus remaining of this one, it means Hx plus Hy by x, or from y side Hy plus H of x by y. Okay. This is joint entropy, okay. And mutual information Ixy, then Ixy can be given as from this side Ixy Hx minus H of x upon y. This is complete Hx. From this the uncommon part is reduced, then remaining is the common part, that is the Ixy, that is the mutual information. So, Ixy is equal to Hx minus Hx upon y. From y side this is Hy minus Hy by x, Hy minus Hy by x, so that common part Ixy can be given by this one. Okay. This is the relationship. One relationship in the joint entropy and mutual information in the same Venn diagram. Ixy, then joint entropy Hxy also can be given as Hx plus Hy, then this is Hx plus this is Hy, but this common part is repeated in both Hx also as well as Hy. Okay. So, that one time this common part can be reduced minus Ixy to get the joint entropy. This is also one equation, or Ixy mutual information can be given as Hx plus Hy minus joint Hxy. Okay. These are some relationship between joint entropies, entropy, conditional entropies, mutual information, okay, and so on. Now, we have to write a equation for the conditional entropies that we have also discussed in the last class, and we have proved that Hxy can be given as summation over j summation over k Hx upon y, Hx upon y, conditional entropies. It is given as P P xj comma yk joint probability into log of base 2 1 upon P xj upon yk, that is the conditional probability. Okay. This we have proved already for entropy Hx upon y, entropy of x when y known. Okay. Similarly, we can prove Hy by x also, and that can be given as summation over j summation over k joint probability into log of base 2 1 upon P yk upon xj. Okay. These are the two equations for the conditional entropies. Okay. This is the thing. Okay. Next, chain rule for entropy. Okay. Uh, Chain rule for entropy, chain rule 1 we have already discussed in terms of relative entropy. Okay. Then in terms of relative entropy, the chain rule, that is the equation for the relative entropy, that is suppose d p x like that, p x with respect to suppose y k. Okay. This can be written as summation over j. This can be taken for same source, then there are not two source, but same source, then we can take it as suppose w j is another probability distribution p w j. Okay. p x j upon p w j. Okay. Then relative entropy j is equal to 0 to n minus 1. This can be given as summation over j p x j log of base 2 p x j upon p w j. This is the relative entropy of x over w or with respect to w. P x j and p w j are probability distribution for the same source, okay, but distributions are different. Okay. Similarly, for joint probabilities, we can find the equation for the relative entropy, okay, that is the d of p x j y k with respect to q x j y k. Okay. Joint probability p x j y k of the two sources x and y, and with respect to the another probability distribution q for the joint probability q x j y k. Okay. This can be written like this, summation over j summation over k joint probability p x j y k log of base 2 p x j y k divided by q x j y k. Okay. This is the relative entropy of joint entropy, okay, over joint probability over probability distribution over given over another probability distribution q x j y k. Okay. Then this is the relative entropy. As per the chain rule, we can convert it into j is equal to 0 to n minus 1, k is equal to 0 to m minus 1. P x j y k can be written as summation over p x j y k into log of this one, then log of p x j y k minus log of q x j y k. Okay. These two equations can be written separately. Okay. Summation over j n minus 1 summation over j summation over k p x j y k into uh, one thing. This thing comes with this log of base 2 p x j y k minus summation over j to n minus 1 summation over k 0 to m minus 1 p x j y k, okay, into log of base 2 q x j y k. Okay. Here some part this can be written as some part is missing. We can again write relative entropy of joint entropy P x j y k equals to summation over j n minus 1 summation over k m minus 1 P x j y k into log of base 2 P x j y k divided by q x j y k. Okay. Here these parts can be broken into two parts. Okay. Like that, joint probability x j y k is nothing but the p of x j upon y k into p of y k. Okay. Using this formula, okay, or p of y k upon x j into p of x j. Then joint probability can be broken into the second part, okay, that is the p y by x into p x. Using this one, now it can be written as summation over j n minus 1 summation over k m minus 1 p x j y k, okay, it remains same p x j y k. This is log of base 2. This part can be written as p y k upon x j into p x j divided by p q divided by q y k upon x j into q x j. Okay. Now, this can be written as summation over j summation over k p x j y k log of base 2 p x j upon q x j, this one. Okay. One thing p x j upon q x j plus same thing joint probability into log of base 2 p y k upon x j divided by q y k upon x j. Okay. So that first part, okay, here we can write the first part d p x j y k equivalent to this first part this can be written as summation over j 0 to n minus 1 and summation over k p x j y k, this becomes p x j into log of base 2 p x j upon q x j. Okay, this first part. Remaining second part, okay, if we express p x j into p x j y k equals to p y by x into p x, p y by x into p x into p x and log of base 2, that is p y k upon x j upon p upon q y k upon x j. Okay. Then first part can be written as d of p x j over q x j plus second part can be written as d of p y k upon x j over q y k upon x j. Okay. This is the chain rule basically. That is the joint relative entropy can be decomposed into these parts. Okay. This is the joint entropy. Now, next is the mutual information. Now, come to the main part, that is the mutual information. Then as we have seen in the Venn diagram, this is the mutual information I x y. Then mutual information is the common part of the source x with source y, okay. And its relationship we have already seen. Derivation of expression of the mutual information, as we have discussed that I x y is equal to h x minus h of x upon y. And from here we can derive the expression for the mutual information. Then h x can be given as summation over p x j j 0 to n minus 1 log of base 2 1 upon p x j minus equation for the h x y, okay, j is equal to 0 to n minus 1, k is equal to 0 to m minus 1, p x j y k into log of base 2 1 upon p x j upon y k. Okay. If we this p x j, this can be written as j 0 to n minus 1, k 0 to m minus 1, that is the 1, then it can be written as p x j into p y k upon x j, okay, because p y k upon x j summation over k, that is the 1 into log of base 2 1 upon p x j or minus this thing. Okay. This is the joint probability, this is the joint probability that we can take common. Okay. Then remaining part can be written as I x y equals to double summation joint probability, okay, into log of base 2 this minus this, then this comes as a log of p x j upon y k divided by p x j. This is the expression for the mutual information. Similarly, we can find the I x y using the another equation, that is the I x y equals to h y minus h y by x. Okay. And in that I x y is equal to summation double summation over joint probability log of base 2 p y k upon x j divided by p y k. Okay. Both formulas we can derive using the Venn diagram. Okay. This is about mutual information. Next class we will discuss capacity of the binary symmetric channel.